Welcome to this week's lecture video. Um, I'll pull up a quick agenda for us. The week 3 lecture video will contain a review of the assignment for this week. We will also preview next assignments, and then we'll look at some random examples and other resources to pull together and examples of Linux in the wild and a little bit of entertainment as well. And we'll close it out. I think you guys are maintaining a great pace. You're working well, getting through it, and it's good to see. So just keep it coming, keep doing what you're doing, and everything's going to turn out just fine. So week 3, we had these 3 different assignments here. The command line, so it's kind of an intro to doing some command line commands, and also the ls command was on full display. Let's see if we can pull that up. I'll just click on it. Should work. There we go. And okay, and there is a resource for this. ls command, I gotta be honest, ls command is by far one of the most popular commands. We looked at it a little bit last week. You know, it's very helpful to be able to list out certain things and to see what's happening, what you need, where you're at, what's there already. So ls command is a very basic primitive type of command. We'll pull up, let's see here. Let me pull up my Linux machine, my Kali Linux. So when I do ls, alright, I didn't know what I was going to see. It lets me know, if I first hit present working directory, it lets me know what directory I'm in. I'm in my own home folder. And when I do ls, I can see my other directories and whatnot. So ls is hugely important. So that's good. One of the things is, what if we type ls? It lets us know there's another alias. So if we type ls, you know, -- color auto, it is the same as ls. So it gives us color. I guess without this command, our ls command wouldn't necessarily have color. I'm going to pull up my Kali install. Alright. So we talked about this quite a lot already. If I do ls, what if I do ls with a D star? It will list out all of the things in that directory that start with a D. If I did that with an A as well, with tick A, let's see, it would list them out in that format. If I did just DO, it would list out with the DO, and then the star is kind of like that wild card to replace any type of character after that. So I'm listing out the directories or all the things in my folder that begin with a capital D and a lowercase o. See, is it case sensitive? It is. Let's make this, let's say clear. We'll make it a little bigger. Let's see here. I'm wondering if my window size could get a little bit bigger. I guess it's somewhat okay right now. I think that's more like it. And we have a nice little, a good amount of transparency that's riding behind this. So in the assignment, it said what ls command will show you all the directory contents that end in a lowercase s. The command that will show will be what? And then it says use the cd ... command to go up one directory. So right now, if I'm my present working directory, I'm in the home, but if I want to go back, cd back, and now I'm in the home directory, I can go back again. Now I'm in the root directory. So I went from home to my dthomas folder, and so on and so forth. So there's kind of ways to kind of move around in your file systems, and that's coming up later. Pretty straightforward. I mean, it's nothing too complex with the ls command. You're basically just listing out documents and things like that. And that way you can know what you're going to do next. Similar to opening up a File Explorer window. Yeah, that assignment is pretty straightforward. There is an ls dash shar. I'm going to get back to my home directory, and now let's run that. It won't be that bad anymore. Wow, quite a lot of stuff there. All right, and let's take a peek at what else. Let's see here. Let's take a look at some of the other assignments here. Module 3, you're supposed to go in and take a look at working in the Linux command, and then also the get and help module. So let's get there and take a peek, make sure everything is good there. So module 3 had to do with working in Linux. Let's go in there. Now, even though there is a terminal, Linux does have a GUI. And the same thing for all the CentOS, for example. When we installed CentOS, some of you guys installed it, it had just a command line. There is a way, there's an application that will enable you to create a GUI terminal. And this is kind of the steps that you would take to do it. There's different programs that enable you to run a window. But because this has that administrative type of feel for it, we primarily work in the terminal. We don't really mess around too much in the desktop version. Pretty straightforward stuff. All right, web servers. Okay, database servers. MySQL's a good one. It's all just good stuff. File sharing. You know, right now, kind of the bootleg way to file share is usually through email. It's kind of the way a lot of people will do it. Whether you send yourself a message or store it as a draft or put it in a Google, if you have Gmail, right? You could put it in your Google Drive, and then when you get into your GUI virtual machine, you go on the internet, you pull it up and download it. But there are other setups that you can do. There are shared folders that you can set up that will enable you to share from one machine to the other. You just put in the files, and next thing you know, it's shared between all the other documents and stuff like that. Now, let's take a look at chapter 4. Yeah, this is all kind of somewhat familiar. So I expect you to kind of just breeze right through that. We will look at the next two as well. Head into week 4, you will be doing 5 and 6, and then also searching files. Let's take a look at 5. Now 5 has this lab component, all right, and it has the exam. So now we're really getting into, you know, gaining more skills at working with the command line. We're supposed to be quick and efficient, and so it's important to get comfortable, know your commands, have certain cheat sheets available. We'll be looking at scripts and scripting and aliases and variables, and I think they start you off with doing something like this. Alright, and most commands, some commands will have options, and you put the minus sign, and then after the options you put the arguments. Okay, just like what you saw, we did ls with, you know, minus a for all, and then we put, you know, whatever it is we wanted to do there. Here it is again. We're doing ls. This time you're actually putting in the file that you want to take the ls of. And when you start off with that / there, that is the root directory. So we're going root directory, then the etc, and then ppp. And we're listing out all of the files inside the ppp directory. Alright, there's even a way to use ls to do two different directories. It will accept both with a space. So it's good to know. Date, calendar, history, I type date. In fact, let me pull up the calendar. Date. Let me spell that word. Let me go back there. So if I do cal, the 6th of 2025. Okay, it's not in. It hasn't been downloaded. That's fine. To do the most recent command, you can type an exclamation and then followed by ls. Let's see. We talk about creating local variables. There's also the grep command, echo path. If we do echo, let's see, echo and then with the variable path, these are all of the different directories that are in the path, which is pretty cool. Type echo. Echo is another built-in program. We talked about this before that enabled us to print onto the screen. And we do echo, like for example, hello world, and it just prints that out on my command line. I can direct that into a file. I'm going to call this hi.txt. If I do ls, we can see hi.txt. If I do cat hi, we can see what's in there. Okay, really basic primitive stuff. Now echo does have some options. I'm going to do echo with an E for escape characters, so it will accept escape characters. And I'm going to do a command for I in range print times I. I'm going to store this in I'm going to call this a triangle.py program. So this is a Python script. And the thing about Python is Python can be ran. It's a programming language. It's a high power, high level programming language that can be ran from the command line once you evolve Python. And then what we're going to do is we're going to pipe this with the command python 3 triangle.py. Alright, let's try this again. Okay, I see the problem. One of the problems here is that we didn't escape this out. So I have to do here and here. Let's see, I got this for I and range here. Let's add what's wrong with my code here? Print Alright, and also every time I enter this command into it, it's going to add more to it. So for example, if I do ls triangle pi and do cat triangle pi, it has all of this code in there, so I have to remove this every time. Now it's not there. Now I'm probably good to go now. Let's see. Okay, so we ran a code that created a triangle. That's pretty much all it did. Probably could be a little bit more efficient because the range command just makes this a for loop 10 times, but it starts at 0. And since we're actually using the values, the I values, and our multiplication, I probably could do 1 to 10. Alright, and of course, the file keeps getting written over. This creates another line in triangle.py, so I'll do remove try, then triangle.py, and now run this script again. And now what we're going to have is a triangle with 10 steps. We got 1, 2, 3, 4, 5, 6, 7, 8, 9. Actually, we would need 11 total. Let's be more precise. Okay. So it stops before 11. It's just a little technicality. I'd have to remove the command again. Let's put a new one there. And now we have our little triangle. Just things like that. Pretty nice. What this did, again, let's just understand the command that was entered in. Echo, but with the option to accept escape characters. And then we did a little bit of Python. 2 lines of Python code. We did a for I in the range, and we could have just went, there was a lot of different ways we could have altered this. I could have went with range of 10 and then just modify my I. But we did a 10 for I in the range, which basically creates like a list from 1 to 10. It says to print, and Python accepts spaces, tabs. It doesn't use curly brackets or anything. So we had to tab after the print for the next command. And we had to do this backslash to escape the quotes, because otherwise Echo would have thought that this was the phrase in quotes, because whatever you put in quotes, it turns out to be what gets printed on the screen. But with the escape character, it lets it know that use the literal quote, not the quote to end the quote. And so we're printing the star times I, whatever I is. I starts from 1, so we're going to print it once, times 1, and then it's going to run again, a new line. I is now 2, which means it's going to print the star times 2. I is 3, I is 4, I is 5. It times it by 1 star every time. And we're storing this code into this script, into this file called triangle.py. And then we did a pipe. Pipe is to actually run another command. You can run multiple commands using pipe. And sometimes the commands can be put together. But what this says is just to run, use Python 3 to actually execute the code. And that's what it did. So Echo has its value. I mean, if one needed to create some kind of script to automate something, and you didn't want to have to go inside Vim or anything weird, you could potentially just do it all on the command line, just by using some of those commands there. So just take your time through this. I think this is good. This one actually has a lab. We could take a look at the lab real quick as well. Let's see. So it tells you what you're going to be doing. You're going to be exploring some bash features. You're going to use some shell variables. And we're going to make use of some of the quoting and stuff like that. You could use this, or you can use your own machine as well. So you get a chance to do some of your own stuff here. It's good stuff. The who am I command lets you know what user you are. You can type your name to put out, what type of system you're on. Present working directory, command history, echo high. Yeah. So if I do echo hello student, I get it. Well, I thought, let me see, I'm gonna make sure. Sometimes you need quotes for that. At least in this case we don't. Okay. It's good stuff. Let's do some more. Which date? Good. Command types. CD. Which. The which command is pretty helpful. It lets you know where that command is located. And once you know where it's located, you probably could go in and modify it too. And customize certain things. And it displays the full path to the ls command. So ls is a file that when you use it, the command terminal will run that script and do whatever the ls command does. This shows all the different aliases. So getting into the quotes, they talk a little bit about that. So this is all good stuff, okay? There's a use case for the 3 different types of quotes. It's all right there. These quotes have special features in the Bash shell as described below. To understand single and double quotes, consider that there are times that you don't want the shell to treat some characters as special. So for example, the star character is used as a wildcard. What if you wanted the star character to just mean a literal asterisk? So single quotes prevent the shell from interpreting or expanding all special characters. Often single quotes are used to protect a string, a sequence of characters, from being changed by the shell so that the string can be interpreted by a command as a parameter to affect the way the command is executed. The double quotes stop the expansion of glob characters like the asterisk, question mark, and square brackets. Double quotes do allow for both variable expansion end command substitution to take place. And then the back quotes cause command substitutions, which allows for commands to be executed within the line of another command. That's pretty interesting. Echo today is date. And as you can see, they're using the back quotes to signify you want that command to be executed. If I had just did echo today is, first of all, if I just do echo today is, you get this. But if I do echo today is date. If I do it with quotes, still single, but now back. Okay. You kind of just want to make your way through this step by step. You're going to take your time. This is another way to go about doing this, obviously. So now you're using date as a variable for the actual date. Okay. Notice what the semicolon colon is actually doing here. Okay. You're actually using another statement but on the same line. You're executing another statement. It's similar to what a pipe would do. Here we go again. This time we're doing the AND command. Here's the OR, and that reaches the end there. So that's kind of to get you started on the lab, and then what you'll do is do the quiz after that. Pretty straightforward stuff. Nothing too terribly scary or anything. And I want to talk about a resource that I provided in the files in our ebook section. It's called the Root Linux book. This is one of my favorite Linux books. It's such a great resource. I would definitely have this handy if I were you. Download these books, review them, read them at your leisure. If you plan on taking a test or you get a job where you must know Linux, or if you want to have that skill set that you can add to your resume, make sure that you reference certain books and things like that. And this one to me is a really good one. Talks a little bit about, the basic setups of computers and whatnot, but then we get into some of the basic commands on page 25, and then the regular expressions, which we call regex. Regex, regular expressions, editing text files, and then we're getting into a little bit of shell scripting and streams and sed commands and things like that. This gets pretty advanced. We don't need to get into all of that, even the introduction to IP and the TCP and all of that stuff. It's good stuff, but for our purposes, we're just going to kind of look at some of the first part of this book. There's our basic commands, and as you can see, it seems like almost everywhere you search, the most basic command that will introduce you to Linux is the ls command, which we know all too well by now. Let's zoom in on this. So it turns out that there are some error codes that may pop up. And so this kind of lets you know what the message is if you happen to see something. You don't want to keep trying the same thing over and over again. Here they talk about copy, glob expressions and stuff. Really good stuff. Wildcards, let's see. I love this part. This, and I don't mean to get on a tangent, but this explains how things are transmitted, all right, over electricity. It's the frequencies that can be interpreted as ones and zeros. And these frequencies are measured, or sometimes they're even heard or measured in such a way to where they cannot be mistaken as ones and zeros. And once they come in and get registered and counted as ones and zeros, they then get, decoded and whatnot. And this is all happening at the speed of light, or actually at the speed of electricity, right? Through copper, or through, whatever they have. So if you type "Hello Fred," inputting that, it's written out here, which is then transformed into binary, which then gets transmitted as this type of wave pattern, which goes through the lines. It gets received, decoded, and it comes back out. I don't know. I thought that was pretty neat. But we'll get into, let's see, some reg expressions as well. Let me see if I can modify this. So one of the activities does use gripe, and it looks like some of you guys have already gotten familiar with it. Being able to search and look for things really quickly is key. I like here, it says usually you will use the reg expressions to search for whole lines that match, and sometimes you would like to match a line that begins or ends with a certain string. The insert character specifies the beginning of a line, and the $ character the end of the line. For example, $the matches all lines that start with a the, and hack $ matches all lines that end with hack. And this, for example, if you did starting with something the dot, okay, and dot is another command, star hack star something matches all the lines that begin with the and end with hack, even if there is white space at the beginning or end of the line. And it can get a little bit more intricate and things like that as well, right? We'll talk a little bit more about this. We're going to have a project on this. And as far as editing text, guys, that's going to probably be in the next lecture video. We'll talk a little bit more about that. But yeah. Yep. And I will, let me see if I can play a nice little movie clip. And this is coming from let me see if I can. I'll play something from the cult favorite. Let me see if I can pull it up here. I will close this down. Now, not going to have it run too long, but hopefully you guys are familiar with Mr. Robot. Alright? It's a cult classic and heavily watched, and you'll see a lot of references in the IT world and the IT culture based on that series. And he was all in Terminal. He looks like he was in Vim. Looks like he was coding in Python, and it's kind of some of the things that we have to aspire to be like when we're working in Linux, and being able to switch to just execute, get things done, what we need to get done, learn the ins and outs of the system and whatnot. Pretty interesting stuff. But we're going to end it here. I think that we have a good path forward. There was one activity we didn't quite get into that much, but it has to do with searching files and contents. And let's just quickly preview this before we call it good. I think I did have one student turn it in already. Let me make sure that it's loading properly. Okay, so you're going to be studying about the gripe command, and basically we're going to be searching in a certain file, and you're going to carry out these commands and whatnot. So this will be a pretty good exercise for you. We'll see how that goes. Do what you can. And there are some resources on the Gripe command. We have other Linux ebooks as well, and also we're going to have another lesson on that. I think the other lab, getting help and all that, is going to be in another lab as well. So lots to look forward to. We're going to get into that real soon. But that's it for now. And if you have any questions, please reach out. And I look forward to helping you get through it.